Hi everyone, my name is Hao. I'm sitting in Copenhagen in Denmark. And today, as Magnus said, the presentation will be shared between Nyander from Sweden and me. So I would like to invite Anders to introduce himself to start with.
Yeah, okay. My name is Anders, Alfa Laval, Technology Development, and I'm located outside Lund now.
All right, and I will try to follow your presentation by reading your mind. So give me a hint if you want me to point at a different place.
I will do that. Okay, just some short words about Alfa Laval. You probably know, some of you at least, Alfa Laval. It's a company working with different technology solutions within the fields of heat transfer. I mean, mainly heat exchangers. Could be anything from the small ones in your heat pump at home to the big industrial ones, as you see on the picture here. And then separation technology could be rotating equipment from high-speed separation, decanters, or membranes and filters as well. And then some fluid handling, a lot in hygienic applications for pumps and valves, etc. And we are working in 3 divisions. It's energy division and food and water and marine, and all of them have a relation to the green energy and global environmental targets, etc. that we will see here later. So, yeah, you can please switch. This picture is not so different from the one we saw in the previous presentation, which I think is good. Then we are in line. What is driving our business at the moment is, the growing energy needs globally, and that in combination with stricter environmental legislations, and at the same time we are expecting higher standards of living, and then the globalization creates demand for transportation. And also we have to take care of the water that we are using because it's also scarcity. So in all those fields, the technologies we provide are useful. And as you see here, the EIA graph of how we could, prognosis of CO2 emissions. And if we are going to follow the desired scenario, the sustainable scenario, we would need help from a lot of different technical areas and fields. We have to switch fuels and use carbon capture, etc. Renewables, power to X, and all those things. And also one very important part that is not talked so much about is the efficiency, so that we use the energy that we have produced in an as efficient way as possible. Heat recovery and making every process as efficient as possible. And there, heat exchangers, of course, also is a crucial technology, which we will look into a little bit further in this case that we talked about. So with that, I hand over to you, Hao.
Thank you. Here comes technology. Why are we relevant for Alfa Laval? And this has been a long history and good story, because the thing is, we are trying to promote the thermal energy harvesting to Alfa Laval. The reason being that we foresee, well, not only us and Alfa Laval, also foreseeing that digitalization is the megatrend. They want to digitalize their products, usually are large-scale industrial facilities. And then when they want to make all the machines connected, they want to install IoT sensors, solutions, and all of them will need power supply. But in quite some of Alfa Laval's machine, it is actually challenging to find the reliable power supply. It's either by installing cable or using batteries, which will drain in the different by different intervals. So our solution is to convert temperature difference into electricity directly, without moving parts, without liquids, without chemical reaction. The technology is so-called thermoelectrics. It's a known solution or known technology, but there's always new improvements in how to make the solution more efficient, how to make it more scalable and more affordable. So as shown here, the idea is whenever we have a heat source, it can be a hot pipe, it can be a hot surface, machine surface. Most of the machine will generate heat in one way or another. And then with this temperature difference between the hot surface, well, it can also be cold surface, and the ambient, we can generate some power. And then the power can be used for driving sensors and wireless communication. So suddenly you have a always on IoT solution without need to send the people around to change the battery or to see whether the battery is still alive. And our core competence is actually the material, as said, how to avoid using rare elements, which are all coming from the different parts of the world. And then we can also make it scalable. Since we don't generate any CO2 in the power generation, it's definitely a renewable energy. And also by recycle waste heat into electricity, we actually force into the circular economy. And also by boosting digitalization, we supply smart power for the IoT, we boost digitalization. And then the following part will be based on a concrete pilot test case that we run with Alfa Laval. Back to you, Anas.
Yeah, thank you. Yeah, so currently, or just recently, we have launched a new product or service, which we call a smart heat exchanger, which is basically a service in order to help our customers using their heat exchangers in a more efficient way and helping them to make the optimal service. So here is a slide which is showing, I mean, what is the meaning of all this? Heat exchanger is a good technology, and we will for sure need more of it in the world to make more efficient processes. But currently, the heat exchangers that are installed, it's calculated that if they would have been running as designed or as intended, whatever designed and cleaned as they were supposed to be, we would have the potential to save 2.5% of the world CO2 emissions only by that, keeping the heat exchangers maintained and use them in the way they are expected to be used. The other numbers here, 50 gigawatt hours, that is the energy savings that we are creating today just by the heat exchangers that Alfa Laval service technicians are doing maintenance on for our customers. I mean, and it's, I mean, we're not doing service on all of them, but with that business, we are saving the amount equivalent to about 10,000 wind turbines a year. And we hope to increase this service business a lot. And in order to do that better, we need to connect our heat exchanger to monitor them. And yeah, if you switch to the next slide, please. This is not a very, I mean, it's a slide that you've seen similar from many companies. I will not go into the details about the services, but basically, I mean, in order to deliver those condition monitoring services and performance optimization, we would need data. We could either get it from the customer if they have the data, but in most cases, we will have to install some type of sensor solution to get the data we need and get that remotely. And we prefer to do it wirelessly because it's quite costly to install cables and wires, because the heat exchanger does not have any electronic components at all normally. So if you please switch to the next slide. Here to the left, you see a quite nice picture of an industrial installation, medium size, I would say. But I mean, there are no electrical cables and there are a few sensors, etc. So I mean, connecting a cable here is quite expensive if you don't need it for anything else. And then, I mean, we could go for the option of having a battery-powered sensor kit that sends the data to us. But here to the right, we see then a pilot that we're doing with a technology from TEGnology. We were powering one of our standard sensor kits with one of their devices, and it has been running in our own lab now since, yeah, it's a year now, March last year. And I mean, just by the temperature of the heat exchanger, we've been able to power this device without any problems during this time. And if you switch to the next slide, then we can see that it also makes sense. It's not like a theoretical application, but also that, I mean, we can create enough energy from quite low delta temperatures, which is quite important because, I mean, just because it's called a heat exchanger, it's not necessarily always hot. It can be cooling applications as well. And here we see a graph of temperature logs, and it's not the temperature logs itself that is interesting, but we can see that when we're running at 60 degrees, we get a lot of measurement points, and we get one measurement point every time we get enough energy from this device. And then when we switch off the heat exchanger and it cools down, you can follow the curve and you see that we get fewer samples, but we still get samples at the delta temperature of, say, 15 degrees or something like that, which is not so much. So yeah, and we are tuning that as well. So yeah, makes sense from a technical point of view. And yeah, over to you.
Yes. And this is the power of running a pilot with the big corporates like Alfa Laval, because when we promote or present our solution, one of the most asked questions by the potential customer is how much energy can we generate? But this is an easy question, but we cannot come always with the easy answer, because how much energy we can generate always depends on the working conditions, depends on what temperature do we have and what areas do we have and so on and so forth. But if you keep saying, throwing questions back to our customer is not always a good sign. But here, by running a very concrete user case or pilot case that we can show, we not only generate enough power, actually more than enough power to power real sensor kits. We can also go to some extreme cases where heat is really, really small. I mean, in the lab, the state of the art is we can generate power from a temperature as low as 5 degrees, which basically is everywhere in the industry, I would say. But then, of course, the power, it also depends on how much power you need and what do you want to do, how much data you want to transfer. But the thing is, technical is one thing. The other thing is, can we create a business, not only for technology, but also for our customers and for our customers' customer? What do they benefit from using this new technology? I mean, here is we have put some numbers based on the input from Alfa Laval and Alfa Laval's customer. Basically, we save time, we save money. Well, we save time for sending people around for doing maintenance, and we save time by avoiding potential downtime. And also, we have potential to avoid shipping cost of lithium batteries. It is not a problem for sending one, but suddenly will cost a lot by sending 100 or 1,000 lithium batteries, which goes into every piece of your product. And then we have a return on investment of 3 to 4 years, which in many cases in industry is quite acceptable. And this will, of course, bring a very good user case for us. And that brings us to the end of the presentation. I know we have very few minutes to introduce all the good stories, but the journey definitely will not end here, and we'll be happy to answer your questions.
Thank you so much, guys. We don't have time for questions. So thank you so much, guys.
Thank you. Bye.